Here we will work a few more examples dealing with velocity. For example, here we have a car that moved at 40 kilometers per hour for 2 hours and 50 kilometers per hour for 3 hours. What is the average velocity? Okay, now the purpose of putting this problem is to make you aware that to get the average velocity, we need to use the definition of average velocity. We cannot just take the average of the two numbers. Average velocity, if you recall, is displacement over time. That's average velocity. So to be able to find the average velocity here, I need to find the displacement first and the time. Now the time is easy. The car traveled for 2 hours and 3 hours. So the time is 5 hours. The displacement, the car moved initially 40 kilometers at 40 kilometers per hour for 2 hours. So that's 40 kilometers per hour times 2 hours. And then it moved an additional 50 kilometers per hour for 3 hours. Now, since the sign of the velocity did not get changed, it tells us that it moved in the same direction here. And 40 times 2 is 80 kilometers. The hours cancel. And then 50 times 3, 150. So the overall displacement is plus 230 kilometers. And my average velocity then is 230 kilometers over 5 hours. So it's going to be, I think, 46, I believe. 46 kilometers per hour. That's my average velocity. Okay, let's take another example. We have a submarine here that travels at an average velocity of 20 kilometers per hour for 500 kilometers, 50 kilometers per hour for another 500 kilometers, 30 kilometers per hour for 60 kilometers. Now the first question is, how long did it take it to travel the first 500 kilometers? Okay, now that's easy. Again, we use the same equation. Average velocity is displacement over time. We are given the displacement as 500 kilometers here, and we are given the velocity, and we are asked to solve for the time. So our time is going to be, I'm going to switch these around. T is going to be d over average velocity. And in this case, that's going to be 500 kilometers over 20 kilometers per hour, which is 25 hours. Quite a long time. But submarines can move slow. Now the next question is, how long did it take it to travel the full distance? Okay, it's painful, but we have to do this for the other segments. Now the time for the second segment, if we call this T1, T2 is going to be d2 over average velocity 2. In this case, that's going to be another 500 kilometers over 50 kilometers per hour, and that gives us 10 hours. That's much better. And T3, that's d3 over v3, And in this case, we have 600 kilometers over 30 kilometers per hour. So that gives us 20 hours. So the total time is going to be T1 plus T2 plus T3. So that's going to be 25 hours plus 10 hours plus 20 hours. So that's going to be 30 plus 25, 55 hours. Now, the last question is, what is the average velocity of the submarine over the full distance? Average velocity, like we have discussed before, is displacement over time. Displacement would be the overall displacement, so d1 plus d2 plus d3. Time would be the overall time, the 55 hours that we just calculated. Now the displacement is going to be 500 plus 500 plus 600 kilometers over 55 hours. In this case, that's going to be 1,600 kilometers over 55 hours. So that's my average velocity, 1,600 over 55. Okay, let me calculate this in the side here so I can give you an answer. Okay. 1,600 divided by 55. Come on here, 1,600 divided by 55 equal, okay, it's about 29 kilometers per hour. Okay. Okay, we have another example. A car was at milepost 260 at 7 a.m. and milepost 270 at 7:30 a.m. What is the average velocity of the car? So what we have here is two positions. Position 1, or the initial position, is mile 260, so 260 miles from the border of, in this particular case, the border with Florida, and P final is going to be at mile 270. Now T1 or T initial is 7 a.m. T final is 7:30 a.m. So my displacement is PF minus PI over TF minus TI, which is going to be 270 miles minus 260 miles over 7:30 minus 7 minus 7 a.m. So in this case, it's going to be 10 miles over 30 minutes, or that's going to be 10 miles over 0.5 hours, or in other words, it is 20 miles per hour. Okay, now let's look at this question here. If the average velocity of a car during a trip along a straight road is positive, is it possible for the instantaneous velocity, meaning the velocity at any instant in between, at some point during the trip to be negative? In other words, is it possible that the overall velocity for a trip to be positive, but then the velocity at some particular times to be negative? Okay, we can take examples. What about if we take a person like this and have the person run and then return a little bit here and then continue here? Now, what's going to happen here? Average velocity is displacement over time. Displacement, that's this. Time is Tf minus Ti, the overall time. When we calculate the average velocity, we don't care how we get to it. Here, so in this case, was the velocity at any instant negative? Okay, here it is positive, he was moving in the positive direction, but the velocity here it is negative. So it is possible for the instantaneous velocity to be negative while the overall velocity is positive.